Next chapter, volume of solids. Volume is the amount of space occupied by a solid in 3D. Prisms are solids with uniform cross-sections. This is a triangular prism. It has two identical faces parallel to each other. If we were to cut this solid parallel to these faces, we will see that the cross-sections obtained will be exactly like the two identical faces. This is a different prism. The cross-section now is a pentagon. A cylinder has a uniform circular cross-section. It is a circular prism. A pyramid is not a prism because the area of the cross-section reduces progressively upwards. A cone is similar to a pyramid except that it has a circular base. It is not a prism either. The general formula for finding the volumes of prism is volume is equal to cross-section area times length. For this triangular prism, the cross-section is a triangle, and so volume is equal to the area of the triangle times the length. Area of the triangle is equal to a half base times height. This is equal to a half times 9 times 10, and then we multiply by 11 to get volume, and so volume is equal to 495 cubic centimeters. This is also a prism because it has a uniform cross-section. In this case, it is a trapezium. And so volume is equal to the area of the trapezium times length. A half times 9 plus 13 times 10, and then we multiply by 8. For a cylinder, the cross-section is a circle. In this case, the length will be the height. Volume is equal to area times height, that is pi r squared times height. Let's take an example. The cylinder is made up of a material 1 centimeter thick. The internal diameter is 12 centimeters and the height is 22 centimeters. If the cylinder is open at the top, calculate the volume of the material used to make it. The solution: to find the volume of the material, we find the entire volume and subtract the internal volume. We start with the external volume. If the material is 1 centimeter thick, then the external diameter is equal to 12 plus 1 plus 1, and that gives us 14 centimeters. Volume is pi r squared times height. That is 22 over 7 times 7 times 7 times 22, which gives us 3,388 cubic centimeters. Internal volume. When calculating the internal volume, you must bear in mind that the thickness of the material includes the base as well. And so the internal height is 22 centimeters minus 1, which gives us 21 centimeters. Volume will be equal to 22 over 7 times 6 times 6 times 21, and that gives us 2,376. Volume of the material is equal to 3,388 minus 2,376, and that gives us 1,012 centimeter cubed. Next solid, cone. To find the volume of a cone, let us perform an experiment. Take a cone and a cylinder with the same radii and heights. Fill the cone with water and transfer the water to the cylinder. Repeat this until you fill the cylinder. You will notice that 3 cones are needed to fill the cylinder. It follows therefore that the volume of the cylinder is 3 times that of the cone. Put in another way, the volume of the cone is the third that of the cylinder. Volume of the cylinder is given by pi r squared times height. It means therefore that the volume of a cone is given by a third pi r squared times height. This is the formula for finding the volume of a cone. And so for a cone with base radius 7 cm and perpendicular height 12 cm, volume is equal to a third times 22/7 times 7 times 7 times 12, and that gives us 616 cubic centimeters. Next, frustum. A frustum of a cone is created by slicing the top of the cone. So when we cut a right circular cone with the plane parallel to the base of the cone, then the solid shape between the plane and the base of the cone is called the frustum of the cone. Chopping also produces a smaller cone. The smaller cone is similar to the large original cone. Therefore, the ratio of their sides is proportional. Using the concept of similarity, calculating the volume is easy. Volume of the frustum is equal to the volume of the large cone minus the volume of the small cone. Let's take an example. Find the volume of this solid. Before cutting off, this was the original cone. We give the height of the smaller cone h small and the entire cone h capital. Notice that h capital is equal to h small plus 5. Let's use similarity to find h. R capital over r small is equal to h capital over h small. And so 6/3 is equal to h plus 5 over h. Cross multiplication, 6h is equal to 3h plus 15. 3h is equal to 15 and h is equal to 5. And therefore, if h small is equal to 5 centimeters, then h capital is equal to 5 plus 5, which is equal to 10 centimeters. Now we can calculate the volumes. We start with the large cone, and volume is equal to a third pi r squared times height, that is a third times 3.142 times 6 times 6 times 10, that gives us 377.04 cubic centimeters. Volume of the smaller cone, a third pi r squared times height, a third times 3.142 times 3 times 3 times 5 will give us 47.13 cubic centimeters. Volume of the frustum is the difference between these two volumes. 377.04 minus 47.13 will give us 329.91 cubic centimeters. There is another direct method of calculating the volume of the frustum without having to calculate the volumes of the small and large cones. Consider a frustum of a cone with base radius r capital, top radius r small, and a height of h. Volume of the frustum is equal to a third pi h into r capital squared plus r small squared plus r times r. Let's try the formula with the solid. R capital is equal to 6 centimeters, that is the larger radius. R small is equal to 3 centimeters and h is 5 centimeters. Substituting these values, volume is equal to a third times 3.142 times 5 into 6 squared plus 3 squared plus 6 times 3. That will give us a third times 3.142 times 5 times 36 plus 9 plus 18. That will give us a third times 3.142 times 5 times 63. And finally we get 329.91 cubic centimeters, the same volume. Next, solid pyramid. A pyramid is similar to a cone, only that a cone takes a circular base, but a pyramid can take any shape, with the simplest being a triangle. The distance from the center of the base to the apex is called the perpendicular height of the pyramid. Volume of the pyramid is given by volume is equal to a third times base area times height. For example, in this pyramid, the base is a square, and so we need to get the perpendicular height to be able to calculate its volume. We shall calculate the perpendicular height using the Pythagoras theorem. If we join the line here, then this distance will be 6 centimeters. Now we have a right-angled triangle. H squared is equal to h squared minus 6 squared. 64 minus 36 will give us 28, square root of which is 5.29. That is h. Volume is equal to a third times 12 times 12, the base area, times 5.29. That will give us 253.92 cubic centimeters. Cutting off the pyramid at a given point along the perpendicular height results into a frustum. The original pyramid and the smaller pyramid obtained are similar. Volume of the frustum is equal to volume of the larger pyramid minus the volume of the smaller pyramid. For example, calculate the volume of this frustum. This is the original pyramid. Let's give this height h capital and this small one h small. We see that h capital is equal to 15 plus h small. And so using similarity concept, 8 over 12 is equal to h over h plus 15. Cross multiplication, 12h is equal to 8h plus 120. 4h is equal to 120. And therefore h small is equal to 30 centimeters. Therefore follows that h capital is equal to 30 plus 15, giving us 45 centimeters. We can now calculate the volumes. Volume of the larger pyramid is equal to a third times 12 times 12 times 45. That gives us 2,160 cubic centimeters. Volume of the smaller pyramid is equal to a third times 8 times 8 times 30, which gives us 640 cubic centimeters. Volume of the frustum is the difference between the two volumes. 2,160 minus 640 gives us 1,520 cubic centimeters. Lastly is the volume of a sphere. The volume of a sphere of radius r is given by the formula. Volume is equal to 4 over 3 times pi r cubed. For example, the volume of a sphere of radius 28 centimeters is equal to 4 over 3 times 22 over 7 times 28 times 28 times 28. That gives us 91,989.33 cubic centimeters. The volume of a hemisphere is given by half the volume of a sphere. That is 2 over 3 pi r cubed.
The second thing I love about math is it's a puzzle-solving kind of, if I can figure it out, and the joy of figuring it out, the kind of sense of accomplishment, the sense of excitement when you get it, the challenge of trying to get it. It's that puzzle-solving kind of thing that I really like.